Hello my dear students, this is Reema. So today in this video we will be moving on to page number 112 of motion chapter class 9 CBSE. We will be solving the numerical problems of the motion chapter. Those who have not subscribed to my video, please do subscribe to my video, and also don't forget to click on the bell button so that you'll get notified when I add a new video. So let's get started with question number 1. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So we'll first write whatever is given in the question first. Okay, so it will be easy for us to solve the problem. Okay, so an athlete completes one round of a circle. So our track is circular. Okay, our track is circular. An athlete comes. So the athlete is starting from here. Completes one round of a circular track. One round means about one round. So it starts from, so maybe it's A. Starts from A. Again he comes to A. Okay, reaches A. And that is what completes one round of a circular track of diameter. The diameter is 200. Okay, so one round means what? What is that? The perimeter of the circle, right? So here it is given diameter. Diameter is 200 meter. So what will be the radius? Radius will be 100 meter. 200 by 2, that is 100 meter. And now athlete completes one round, means what? The perimeter of the circular track. Perimeter of the circular track. How much? 2 pi r, right? Which is equal to 2 pi into 100, which is equal to 200 pi meter. Okay, so what is given here? Athlete complete one round of a circular track 200 meter in 40 seconds. So one round is how much? One round is equal to 200 pi meter. Okay, so this you have to keep in mind. And he covers one round, that is 200 pi meter in 40 seconds. So in 40 seconds he covered one round. Okay, keep this also in your mind. Now the question is, what will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So the total time is given. So total time is equal to 2 minutes 20 seconds, which is equal to 2 minutes 60 plus 60 120, 120 plus 20, that is 140 seconds is our total time. So now we have to find what? Distance covered and displacement. So we have to find how about all distance and displacement. Okay, so we have in 40 seconds the athlete covered one round. So the total how much it is? 140 seconds. So 40 seconds he covered one round. By unitary method, in 1 second he will cover 1 by 40 round, right? So in 140 second how much he'll cover? 1 by 40 into 140, that is how much? 7 by 2 round, which is equal to, we have solved this in our Similar case in our previous problem of this chapter. Okay, so this will be 3.5 round. How will got 3.5? 7 by 2 is what? 3 2s are 6 and 1. So 3 1 by 2. Okay, so this will be 3.5 round. So the total distance means what? 3.5 round, right? Total distance means what? The total distance covered from the start and the end point. So distance means what? 3.5 round means what? 1 2 3.5. Okay, so we know one round is, we have found it later, 200 pi meter. So 3.5 means what? 7 by 2. No, I'll write 7 by 2. So 7 by 2 round is how much? Rounds is how much? 7 by 2 into 200 pi. I'll write pi as 22 by 7. Okay, so 7 and 7 get cancelled, and 2, this will be 100. So it will be 2200 meter. So our total distance is how much? 2200 meter. So now we have to find the displacement. So what is the displacement? Displacement means the shortest distance between the initial and the final point. So 3.5 means what? 1 2 3.5. So this is our, what is final point, final position. This is our starting position and this is our final position. So what will be the shortest distance between this? This will be the diameter of the circular track. You understood, right? So displacement will be the diameter of the, so total displacement is how much? Is equal to the shortest distance between the starting and the final position. Okay, that is diameter equal to diameter of track. Our diameter is given how much? 200 meter. So this is how we solved this problem. So next question is question number 2, that is Joseph jogs from one end A to the other end B of a straight 300 meter road in 2 minutes 30 seconds and then turns around and jogs 100 meter back to point C in another 1 minute. What are Joseph's average speed and velocity in jogging? First question from A to B and second one from A to C. So we have to find the average, how much, what all? Average speed and average velocity from point A to B and from point A to C. So first we'll draw and see what the question is saying. Joseph jogs from one end A. Okay, Joseph starts from here. One end A to, on a straight road, to other end B. Okay, of a 300 meter road. So this is 300. A to B is 300 meter. In how many, in what time? 2 minutes 30 seconds. Okay, and then turns around and jogs 100 meter back. So he turns around and jogs 100 meter. Okay, this is 100 meter and this is the point C. In how many minutes? 1 minute he has taken. Okay, now we have, okay, all these things and we will now see from first question we'll take. Okay, from A to B we will take. Okay, first thing we have to find what? Average speed and average velocity. So what is average speed? Average speed is equal to total distance traveled by total time taken. So average speed is equal to total distance traveled by total time taken. So this is from A to B. Okay, from A to B, how much he traveled total distance? That is 300 meter, and the time is what? 2 meter 30 seconds. So this will be total distance is 300 and total time is 2 minutes 30 seconds. Means what? 2 minutes means 60 plus 60, that is 120. 120 plus 30, that is 150. So we'll cancel this. It will be 2. So average speed is 2 meter per second. Okay, now we have to find average velocity. So average velocity is what? Total displacement. Okay, total displacement by total time taken. Total time, which is equal to what? He traveled from A to B. Okay, we have to find the first condition, that is A to B. From A to B, A is starting and B is the ending position. So here also the distance will be how much? 300, and time taken will be same. Okay, that is 150, which is equal to 2. That is 2 meter per second. Here also the average velocity is how much? 2 meter per second. Okay, and now we have to find our second condition, that is from A to C. Okay, here also we have to find what? Average speed. Sorry, speed. Average we have to find, and how much? Velocity. Average we have to find. Okay, here also same thing. Average speed is total distance by total time taken. So speed average is equal to total distance by total time. So C, from A to C, how much is the total distance? He traveled from A to B and then he returned back from B to C. So distance will be 300 plus 100, right? And time will be how much? This much, he 2 minutes 30 seconds. That is from A to B 2 minutes 30 seconds plus from B to C 1 minute. So 3 minutes 30 seconds. Okay. So distance is 300 plus 100, which is equal to 300 plus 100 is 400 divided by total time is 3 minutes 30 seconds. So 60 plus 60 plus 60, 180 plus 30, that is 210. Okay, which will be 1.8 meter per second. Okay, and now what will be the average velocity? So velocity average is equal to total displacement by total time. So we'll again check our diagram. Okay, so here what Joseph went from A to B and returned back to C. So A will be the initial position and C will be the final position. So what is the distance between A, shortest distance between A and C? A and C will be 300 minus 100, right? 300 minus 100. Okay, so this will be how much? 200. 300 minus 100 is 200 divided by how much time he has taken. How much time means what? 2 minutes 30 seconds plus 1 minute. So this will also be 3 minutes 30 seconds. That is 210 seconds. So this will be 20 by 21. So this will be equal to how much? 0.95. Okay, 21 nines. Okay, this is 1.9. Okay, this is 1.9 meter per second. Okay, so not 1.8. Okay, so the average speed is 1.9 meter per second and average velocity is 0.95 meter per second. Okay, this is how we calculate the average speed and average velocity. And now our third question is, Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed of Abdul's trip? Okay, so Abdul was driving to school. Okay, from A, this is his home and this is his school. Okay, and now the average speed for his trip to be 20 km per hour. Traffic was there. Okay, and on his return trip along the same route. Okay, so same distance. Okay, there is less traffic and the average speed is 30 km per hour. So we have to calculate the average speed of Abdul's total trip. Okay, so now we know the distance will be the same, no? Distance A, B, while going to the school and returning back, all will be the same. So the distance between Abdul's home and school is, let it be what? D. Okay, let the distance be D, for example. Okay, now we have the average velocity while going to the school is 20. Average velocity means what? Total distance by total time taken. Let T1 be the time taken to go to school. Okay, time taken to go to the school. So this route A to B is how much? T1. Okay, and now we have what? Average velocity, that is velocity from A to B, that is V1 will be what? Average speed will be what? That is distance by time, that is T1. So we have V1. V1 is what? V1 is given as the speed for a trip to be 20 km. First speed is 20 km, so that will write 20 km per hour. So now you have V1 is equal to 20 km per hour. Okay, so what? D. The distance is what? D, no? The D from A to B, it's D. So D by T1 is equal to 20. So what will be T1 here? T1 is D by 20, right? And now we have on returning back. Okay, let T2 be the time taken while returning from school. Okay, so from B to A he has taken time T2, and now we have V2 is given here as what? It's given here, see, it's given due to the less traffic, the average speed is 30 km per hour while returning. So here V2 is 30 km per hour. And now we know V2 is how much? Distance, total distance by time taken. So distance by time taken here is how much? T2. And we know V2 is how much? V2 is 30. So how much will be T2? So hence T2 will be D by 30, right? We have D by 30 now. T1 is how much? D by 20, and T2 is D by 30. And now we have to calculate the average speed of the Abdul's entire trip of what is the average of entire trip, which is equal to how much? Total distance by total time. You know how much is the total distance? We have taken A to B as D, no? So B to A will be also D. So total distance will be D plus D, which is equal to 2D. Okay? And total time taken. So time is what? T1 plus T2, right? T1 is D by 20 and T2 is D by 30. So it is D by 20 plus D by 30. So how much it will be? 2D by we'll get the LCM how much? 60. So 20 into 3, so D into 3. So 3D plus 30 into 2, D into 2. 2D by 60. So 2D by D by 20 plus D by 30. So we have taken the LCM and now we got 2D into 60 by 3D plus 2D is how much? 5D. And D will get cancelled. 5 into 12 is 60. So 12 into 2 is how much? 24. So the average speed of the entire trip will be 24 kilometer per hour. Okay. And now moving on to our fourth question. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? Okay, a motorboat is starting from rest. So whatever is given in the question we'll write first. So it is at rest. So U will be how much? U will be 0. From rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square. So we have acceleration is equal to 3 meter per second square. And time is also given 8 seconds. T is equal to 8 seconds. So now we have to find how far does the boat travel during the time. So that is we have to find the distance or displacement. Okay, so here we have U, we have A, we have T. So which equation of motion we have to take? Second equation of motion. So second equation of motion, that is S equal to UT plus half AT square, right? So here which is equal to UT is what? 0 into 8. 0 into 8 is 0. 0 plus half A is how much? 3 into T square. So T square is 8 into 8. Okay. 2 will be cancelled. So 12 into 8 is how much? 96 meter. So the boat will travel 96 meter during the time period of 8 seconds. Okay. Okay, now we move on to our fifth question. Okay. The driver of a car traveling at 52 km per hour applies brake and accelerates uniformly in the opposite direction. The car stops in 5 seconds and the driver going at 3 km per hour in another car applies his brake slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graph for the two cars. Which one has traveled farther after the brakes were applied? Oh, it's a lengthy question, right? So don't worry seeing the length of the question. It's actually very easy, okay? First, we will analyze what the question is telling us, okay? So the driver of a car traveling at 52 km per hour. So whatever in the question we'll write first, okay? So what is given? The car traveling at 52 km per hour applies brake. So the speed will decrease and it will go to rest, okay? So driver of a car traveling 52 km per hour. So first car, okay? First car I'll write. then it's traveling at, so u is what, 52 kilometer per hour. When converted to meter per second, it will be 52 into 5 by 18. So this will be 14. When calculated, it will be 14.44 meter per second. Okay. And now the brakes are applied in the opposite direction. The car stops in 5 seconds. Okay, the car stopped, then how much t is equal to 5 seconds. Then v became 0. Okay. Another car, okay, second car I'll write. Second car. Another car going at 3 km per hour. So u is, for this car, u is 3 km per hour, which is equal to 3 into 5 by 18, which is equal to 0.83 meter per second. Okay, so we have the time is given how much, 10 seconds. Okay, time is given 10 seconds and v is equal to 0. Now we have to plot this. Okay, so how will we plot a I'm just showing it roughly. Okay, you have to plot in the graph. Okay, graph paper. So both the cars we have to plot in one graph. Okay, so this will be our time. We have to plot it in the velocity vt graph. Okay, velocity will be here, velocity. Okay, and now for the first car, how much it is showing? Okay, that is 0. Okay, we'll take 5 here, we'll take 10 here, it is seconds. Okay, and here how much it is? We'll take 5, 10, 15, like that will take. Okay, so t will be 5. So our initial velocity is how much? 14, right? Initial velocity is 14.4. Okay, so initial velocity will be here for the first car, and then it will come to rest. So we have studied, right, for the uniformly accelerated decreasing motion. Okay, our graph will be like this. So this will be the graph. Okay, this is 5. This will be the graph of car A. Car 1, I'll write car 1. Okay, and next for the next one, how much is the initial speed? Is 0.83. So not speed. Okay, initial speed is how much? Yeah, 0.83. So I'll take it somewhere here. Then it is going to rest. Okay, so this will be car 2. Okay, so here what we have to find, next question is, which one has traveled farther after the brakes were applied? So we have to find what? We have to find the displacement. Upward displacement of car 1 and car 2. So first one, displacement of car 1. Okay, displacement of car 1 is what? We have studied that displacement will be the area under the graph. Okay, area under the graph, right? So the area under the graph is what? This area for the car 1, and the area under the car 2 means what? Area under the graph, this area. So the area for the car 1 will be area, will write A. Okay, this is O, and this I'll write B, and this one I'll write what? A or B. Then C I'll write here, and this I'll write D. Okay, so the area of triangle what? AOB, which is what? Half BH. You know half BH, no? So half B is what? B is the base, OB. OB into H is what? AO. So it will be half. OB is 5. And Height is how much? This is how much? This is actually 14.44, right? And this is how much? 0.83, right? Okay. So 5 into 14.44. Okay. We will get 36 meter. Okay. So now we have to find the displacement of car 2. Okay, we don't know that, so we have to, that is area under the triangle. So this is our triangle COD, area of triangle COD, which is what? Which is half BH, right? Half BH, which is half into B is what? OD, right? OD into height is what? Height is OC, which is half into OD is how much? OD is 10 and OC is how much? OC is 0.83. So when we calculate, we'll get 4.15 meter. So which car has traveled? The question is, which one has traveled farther after the brakes have applied? So car A has traveled 36 and car B has traveled 4.15. So which one is traveled more? So car 1 has traveled more. Okay. So you have to write that also. Okay, fine. Okay, so this is all for today's session, and I hope you all have subscribed to my channel. If you like my video, please support me by pressing the like button and do write your valuable comments. We'll surely come back with another lesson to make it easy for you. Thank you.